Now we're going to look at simplification in logarithm. So in this lesson, we shall be applying the laws we just learned that applies to logarithm. So like the multiplication law, division law, and the one that governs a number that's raised to power, or logarithm number that's is written in index notation. So we shall be applying those rules, those laws, to solve problems on logarithm, especially the cases where we don't need to use tables. Okay, so let's proceed. So number one, simplify log 4 plus log 8. One thing you should take notice that if you observe, you will see that there is no base given here, and that's because usually is by practice you don't usually write the base when it's in base 10. So if it's not in base 10, the base will be written to be indicated, but sometimes they omit it if the base is in base 10, but sometimes they write it like you can see this is base 10, so it's written. But most times, if you don't see any base here, it's in base 10, so you don't need to panic, just solve and apply the laws. So since it's addition, it implies that going to be log 4 times 8, and that's equal to log 4 times 8 will give us 32. Since it's in base 10, this will be our final answer. 32. Simplify log 3 54 plus log 3 15 minus log 3 10. That will give us log. Now addition and subtraction, so that will give us 54 times 15. Here you have addition. This addition is between these two, so you multiply the logarithm values together, the logarithm numbers, and then you're going to divide by this one that you have the subtraction sign before it, so divided by 10. So here we go as 5 into 10 will give us 2, 5 into 15 is 3, and 2 into 2 is 1, 2 into 54 is 27, 27 times 3 is equal to log 3 is 1. So we can continue. Log 81 to the base 3 is 3 raised to power 4. 3 times 3 is 9, 3 times 9 times 3 is 27, 27 times 3 is 81. So this is written as 4 log 3 to the base 3. And I told you that the logarithm of any number to its base is equal to 1. So this is equal to 4 times 1. That's equal to 1. Alright, so number 4. Oh, okay, let me just put it this way. So that says since log 3 to the base 3 is equal to 1, therefore 4 log 3 base 3 is equal to 4 times 1, which is equal to 4. So that's it. Then number 3, evaluate log e raised to power 3 to the base a, and this will give us 3 log e to the base a. Since log e to a is equal to 1, therefore 3 log e to the base a is equal to 3 times 1, that's equal to 3. Number 4, without using tables, evaluate 2 plus log 20 to the base 10 minus log 2 to the base 10. Okay, now this part here, don't just put 2 then multiplied by 20 divided by 2. No, it won't work. This 10, we're going to say but 2 is equal to, now since the base here is, the common base is 10, so that implies that 2 is equal to log 10 raised to log 10 raised to power 2 to the base 10 to the base 10. Okay, so which implies that 2 raised, since it is in this form, in 10 raised to power 2 is in index form, bring your 2 backwards, 2 log 10 10. So this tells you that Logarithm of 10 to the base 10 is equal to 1. So 2 times 1 is equal to 2. That's why here is 2. So we replace this 2 with this what we have here. So we can rewrite this expression as 2 log 10 to the base 10 plus log 20 to the base 10 minus log 2 to the base 10. So now that we have this, we can now multiply. So before we multiply, let's also write it again. Log, bring this one back. Log 10 to log 10 raised to the power 2 to the base 10 plus log 20 to the base 10 minus log 2 to the base 10. So now we can apply the laws of logarithm. So for addition, we're going to multiply. So that's 10 raised to the power 2 log 10 raised to the power 2 times 20 over 2 over 2. So 2 here 1, 2 here 10. This will give us log 10. 10 raised to the power 2 is 100 times 10. And that will give us log 100 times 10 is 1000. 10. And that will give us log 10 raised to the power 3. So this will bring it backwards 3 log 10 to the base 10. I will say but log 10 to the base 10 is equal to 1. So therefore 3 log 10 to the base 10 is equal to 3 times 1. That's equal to 3. My answer. Number 5. Simplify log 8 to the base x minus log 2 to the base x plus log 4 to the base x. Now you know that when there's addition, you multiply, and for subtraction, you divide. So we're going to rearrange this, bring the positive log to one side, group them together. So log 8x is positive, and this one is also positive, plus log 4 to base x, and then this is negative minus log 2 to the base x. Let's note that the sign before any number or any algebraic term is what determines whether the sign is that term is positive or negative. For instance, if I have 3a plus 2a minus 2 minus 6a, and assume I want to group them based on their signs. Okay, let's also add. Let's say this is minus, and then let's say plus, and let's say this is plus 3a again, and let's say this is 4a. And so I want to group this based on their sign. Since the letters are the same, I want to group them based on their sign. This one, the sign before this one is positive, and but we don't usually write it because it's the first term. So if it's negative, you will see a minus sign before it, and usually if it's negative, the sign must be written. That's how you know that this first term is negative. But if there is no sign in front of this first term, 3a, that means it's positive. Then this next one, 2a, this sign is for 2a. So you don't just say 2a, you say minus 2a. Then for this term, this sign is attached to 6a. It's attached to it. So if anyway this one goes through, this sign follows. So assuming this sign is going to, assuming you want to bring 6a over to this side, then this sign will follow. So it will cross with 6a, and when it crosses, it becomes minus 6a. You know how important that is when we compute either when we collect like terms. But so now also this center plus, this plus is for 4a also for this term. So don't mistake, don't miss it when you need to collect terms. So if you are to group this again, this becomes 3a plus 6a plus 4a, then minus 2a in terms of the signs. This is how you arrange it. So the same thing applies to what we have here. This minus is for this third second term, and this one is positive because there's no minus sign here, so it's positive, and this plus sign is for this third term. So when you group them based on sign, plus that is positive, positive, this one is positive, this one is positive, you bring them together, and so it's negative. Now we do this because we're going to apply the laws of logarithm. So where we have addition, we're going to multiply. So this becomes logarithm 8 times 4 to the base x over, so here you have subtraction, you divide. So that's why this arrangement was essential. So 2 here, 1, 2 here, 2. And this will give us log 8 times 2 is 16 to the base x. So that's the final answer. Number 6. Simplify log root 100 to the base 10. So this will give us 100 raised to 1 over 2. From indices, we know that root 100 is equal to 100 raised to 1 over 2. Here we have it e equal to e raised to 1 over 2. So this will give us log. So we write this in index notation. 10, sorry, in index notation to be 10 raised to power 2. Meaning that 10 multiplied itself 2 times. 10 times 10 to give you 100. 1 over 2. So this 2 times 1. So this is where understanding or knowing the laws of indices help, because now you know that this is in indices, this is the way you go about this particular type of problem. So 2 times 1 will give us 2, and then 2 divided by 2 will give us 1. So that will give us 10 raised to 1, or 10 raised to 1 to the base 10. And 10 raised to 1 is equal to 1. Either I say 1, bring the 1 here, though it's not going to be significant. 1 here, log 1 log 10 to the base 10, and we say but log 10 to the base 10 is equal to 1. So therefore 1 log 10 to the base 10 is equal to 1 times 1, that's equal to 1. Or from here, we already know that 10 raised to 1 is 10, so we just say logarithm of 10 to the base 10, that's equal to 1. So instead of bringing this 1 here, since it's just 1 times anything here is still going to be 1. So and then log 10 to the base 10 is 1, so we get 1 as a final answer. Number 7, log 10 45 plus log 45 to the base 10 rather, plus log 9 raised to minus 1 to the base 10 minus log 2 raised to minus 1 to the base 10. So addition, which gives us log 10 log to the base 10, 45 times 9 raised to minus 1 over 2 raised to minus 1. And then this will give us log, and then 45 times, now 9 raised to minus 1 is equal to 1 over 9 over, and here 1 over 2. So 9 here 1, 9 here 5. And so this will give us log to the base 10. 5 times 1, 5. So here's division. So that's 5 divided by 1 over 2. Okay, so this can also be written as log to the base 10, 5 times 2 over 1. We change the division sign, and then this part of the fraction will be affected. 5 times 2, 10. 10 divided by 1 is 10. So that will give us log 10 to the base 10, and this is equal to 1. Number 1, simplify. Log 10, 18 plus minus log 2.88 to the base 10 plus log 16 to the base 10. So let's rearrange log 18 plus log 16 minus log 2.88 to the base 10. So this will be equal to log 10, 18 times 16 over 2.88. So let's find out what 18 times 16 will give us. 18 times 16, 6 times 8 is 48. 6 times 1, 6 plus 4, 10. 1 times 8 is 8. 1 times 1 is 1. 8, 8, 2. That's just 288 over 2.88. So we need to, so for us to continue with our, to get the solution to this expression, what we're going to have to convert this to whole number, this part 2.88 to whole number. For us to do that, we're going to multiply the denominator by 100. And whatever we do to the denominator, we must also do same to the numerator. So we multiply both sides, both numerator and denominator by 100. So let's multiply both numerator and denominator by 100. So this will give us log 288 times 100 over 2.88 times 100. And this will give us log 28800 over 288. So this here, 288 into 288 will give us 1. It will give us 1. And so here will give us 100. And this will give us log 10, log 100 to the base 10. And that will give us log 10 raised to the power 2 to the base 10. And then this will give us 2 log 10 to the base 10. But shape but log 10 is equal to 1. So therefore 2 log 10 to the base 10 is equal to 2 times 1. And that's equal to 2. Number 2. Simplify log root 8 over log 4 minus log 2. So let's simplify the denominator. So first simplify the denominator. Log 4 minus log 2 is equal to log 4 divided by 2. So that since there's no base was written here, it shows that the base here is base 10 and that here is also base 10. So that will give us log 2. So we're going to put this here and then we're going to say therefore log root 8 over log 4 minus log 2 is equal to log root 8 over log 2. And that is equal to, since it's division, and that gives us log root 8, which is equal to log root 8. Okay, so that this will be 2 raised to the power 3 raised to 1 over 2 because of this root and over log 2. And so this will give us, now 3 times 1 will give us 3 raised to, this will give us log 3 log 2 raised to 3 over 2 divided by log 2. And this will give us, we'll bring this one here, 3 over 2 log 2 over log 2. So log 2 will cancel log 2. So you have the final answer to be 3 over 2 is equal to 1 over 1 over 2. Number 3, simplify log 3 minus log 2 over log 9 minus log 4. And since we have subtraction here and subtraction here, this will give us log 3 over 2 over log 9 over 4. This will give us log 3 over 2 over log 3 over 2 raised to the power 2. And that will give us log 3 over 2 over 2 log 3 over 2. So since they are similar, cancel 1, sorry, we left it 1 over 2, which is also equal to 0.5. Number 4, simplify log 125 over 8 minus 2 log 5 over 4. And this will give us log 10 log 125 over 8 minus log Okay, so 1 to 5, this will give us 5 over no problem. Let me just use like 1 to 5 over 8 minus log 5 over 4 raised to the power 2. So since it's subtraction, we're going to divide log. So 125 over 8 divided by 5 over 4 squared. And this will give me log 125 over 8 times 4 over 5 all squared equal to log 125 over 8 times 16 over 25. 8 here 1, 8 here 2, 25. 5 here 5, 5 here 25, 5 here 1, 5 here 5. 5 times 2 is 10. That's log 10. And this is equal to 1. Number 6. Log root 65 to the base 10 plus log root 2 minus log root 13. And this will give us log root 65 times root 2 divided by root 13. This will give us log root 65 is equal to root 5 times root 13 times root 2. And this will give us root 13. So this will cancel, log 10 root 5 times root 2. And this will give me log 10 root 10, which will give me log 10 raised to 1 over 2. And this will give me 1 over 2 log 10. Say both log 10 to the base 10 is equal to 1. So therefore 1 over 2 log 10 is equal to 1 over 2 times 1. And that's equal to 1 over 2. Number 1. Without using tables or calculator, evaluate log 75 over 10 minus 2 log 10 5 over 9 plus log 100 over 242. So let's rearrange. Or we already know that this what is positive and this is positive. So 75 over 10 times 100 over 242 divided by 5 over 9 raised to the power 2. So this is equal to 75 over 10 times 100 over 242 times 9 over 5 raised to the power 2. So 75 over 10 times 100 over 242. 9 raised to the power 2 is 81. 5 raised to the power 2 is 25. So 0 cancels 0. 5 here will give us 5. 5 here will give you 15. And then 5 here is 1. 5 here is 3. 3 here is 1. 2 here. 3 into 3 is 1. 3 into 3 is 81. 81 into 81 is 1. 81 into 81 is 1. So I'm left with 10. So that will be log 10 to the base 10. And that's equal to 1. That's number 1. Number 2. Evaluate log root 27 over log root 81. And this will give me log 27 1 over 2 over log 81 1 over 2. And that will give me log 3 raised to 3 raised to 3 raised to 1 over 2 over log 3 raised to power 4 1 over 2. And this will give me 3 times 3 times 1 will give me log 3 3 over 2 log 3 4 times 1 is 4 over 2. So this, what I did was from the laws of indices. Now I'm going to, since this is raised to power, I'm going to bring it back. So this will give me 3 over 2 log 3 over 4 over 2 log 3. Now log 3 will cancel, so I'm left with 3 over 2 divided by 4 over 2. This will give you 3 over 2 times 2 over 4. 2 here 1, 2 here 1. That's equal to 3 over 4. Final answer. Over 3 log 27 divided by log 9. This will give us log 2 raised to power 3 log 2 raised to power 2. This will be 3 log 3 log 2 log 2. Log 3 will cancel log 3. So that will be 3 over 2, which is equal to 1 over 2. Number 4. Over 4 plus 2 log 2 plus log 3 over 7. So we multiply all through because we have addition all through here, and this will give us. So let's solve this. 1 over 3 plus 1 over 4. The LCM is 12. 12 into 2 is 4. 4 times 1. 4. 12 into 4 is 2. 3 times 1. 2. So we have 7 over 12. 7 over 12 times 2 raised to the power 2 is 4. Times 2 over 7. So 7 here 1, 7 here 1. 4 here 1, 4 here 2, 2 here 1, 2 here 1. We have here log 10. But log 10, so this is equal to log 1 to base 10 is equal to 0. Remember from the rule that when we are, remember from the lesson on laws of logarithm, as one of the laws is that when the logarithm of 1 to any base, the logarithm of 1 to any base is equal to 0. That is because for this place to be 1, it means it's raised to, let's say, log a raised to 0 is 10. So a raised to 0 in indices is equal to 1, where a raised to 0 is equal to 1. So it's any logarithm of 1 to any base is equal to 0. So log 1 to the base 10 is equal to 0. So this is our final answer. Number 5. Evaluate without using table or calculator. Root 30 minus log 6 10 plus log root 2 10 root 30 times root 2 1 root 6. Root 30 is root 6 times root 5 times root 2 over root 6. So root 6 here 1, 6 here 1. Root 5 times root 2 is equal to root 10. Okay, that's root 10. Root 10. This is root 10 raised to 1 over 2. 1 over 2 to the base 10. So 1 over 2 log 10 to the base 10. But log 10 to the base 10 is equal to 1. So therefore, 1 over 2 log, this will give us equal to 1 over 2 times 1. And that's equal to 1 over 2. Final answer.